I'm Joseph. I'm the director of machine learning at Personally. I did do some funny slides just for you guys to get to know who you're talking to. I'm actually closing. I'm also at my EdTech bar mitzvah, so getting close on 13. I have a great family, way too many pets. 4 data scientists that are way smarter than me. I still find some time for gaming, and I jumped over the joke. But yeah, my life is kind of stressful, that's the point. We're going to talk about the underlying principles of machine learning for our use case, what we're actually doing, how we apply machine learning specifically for us, and what do we do with signal loss, which is like the conversation you just heard about privacy and everything. When it comes to how machine learning works in programmatic, UA, there are a bunch of different stuff we do. It all starts with some sort of cold start approach. When you're starting a new campaign and you don't have information, you have to start off where you don't have the user level and some sort of contextual relationship thing between apps. And when you do have the user level, you can start off with some sort of cohort segmentation stuff that you can start off with. Otherwise, you're going to have a bad time and exploration is going to be way too long. So you're starting off with that approach. You start bidding, you log your data, impressions, clicks, installs, etc., and you accumulate more data and you can start building a model. As soon as you build a model for your ML pipeline, that model is synced to your bidders, and your bidders start using it. This loop that you're seeing here is actually the actual learning part. Every day that goes by, or every few hours, depending on your implementation, you're going to get more information, and you're going to improve your model. That's the whole point, because things change. New publishers are out there, etc. We have close to somewhere between 100 to 300 milliseconds to do a lot of different stuff in programmatic. It comes down to 5 predictions per advertiser that fits the request. We have to predict a click from the impression, an install given a click or an impression, because we have both types of attribution, an event, a post-install event given an install. In some cases, we make it even more particular when we're looking for a specific LTV, or like the whales, we'll go for the top 20% in terms of LTV. And we also have to predict the auction price because we don't want to overpay. Everything is on the first price, meaning if you bid 100 as the first bidder, like the highest one, and the second one is 50, you're going to pay $100 CPM. You don't want to do that if the price of if the market value is 50. So all of this happens very quickly at a very high scale. 3 million requests per second at peak right now, and it's that's probably like a third of like the full potential. We're not fully global yet. When you're looking at DSPs for UA, there are many different ways to categorize them. I chose this one. I think it's the simplest one. You have many self-service platforms and managed platforms that basically don't really use machine learning in a way that is at the impression level. Decisions are still made based on like a combination of different features. In these examples, you can see these line items where for a specific category and a specific ad creative and a specific model, you would bid a specific bid according to your past history, historical performance. This can work, obviously, these companies exist, but it's either very specific or not really scalable and usually very frustrating. This is why the other side of machine learning, so the other type of DSPs, the machine learning-based ones that can really understand these relationships automatically and at higher scale and with more dimensions, are the ones that are becoming more prominent. Talking really about the learning part to say what it means. Yeah. So, as I said before, when we're starting off a new advertiser, we have a cold start problem. We have no information. Even if we get unattributed data through the MMP, we don't know where to buy the impressions, which is the right place. So you need some sort of approach to do this. It can be lookalikes, it can be based on context, it can be a bunch of different stuff. But you have to have something that lets you explore effectively, otherwise you're going to have a bad time. The advertiser is going to call you. You spend $20,000, I have 2 CPAs. What the hell is going on? So you don't want to go there. You need the exploration to also be designed in a way where it doesn't spend too much on things you already know. Let's say I'm promoting Candy Crush. There's no reason to target a 14-year-old kid, right? Or a segment that looks like it. They don't care about it. If they'll install, they won't be with high retention, and they'll definitely not pay. So you need to make sure that your cold start problem is wary of what the advertiser already knows in his data. You don't need to repeat the learning. The last thing, before I explain this nice GIF graph, is overfitting. This is like how you have to balance out your cold start solution. If you're working on a small segment of users and you're training your model only on them, you're going to have what's called overfitting. It's going to expect a very high conversion rate. The mean target rate of the model is going to be very high. And as soon as you want to scale and you're starting to target users that are further away from your context, again, you're going to have a bad time because it's going to see a different conversion rate. And all of machine learning really relies, in our use case, on the assumption that yesterday and today are pretty much the same. The sun is still shining, people are still installing apps. If there's a drastic change, the model would fail. So we want to avoid that. What we're seeing here is a visualization from our backend that really shows this learning process. I'll explain it quickly. The x-axis is the probability of the user installing in this case. It's in groups of 5% from 0 to 100. And the y-axis is the amount of users from the targeted population in that probability range. You can see that on the first day, the first few models, basically 90% of the users have zero probability of doing anything. We don't know anything yet. That makes sense. But over time, each color for line here is a new model that we retrained every day. And as we accumulate information, you can see the distribution becomes more normalized. And we can actually say the user over here is 7 times more likely than installing than the user over here. That's classification. That's what we're trying to do. Last thing here about machine learning. We have demystifying in the name because that's really an important thing to do. ML looks magical, especially now with ChatGPT and generative AI. But in reality, it's a machine that has inputs and outputs. And in our case, the use case is even more simple. We're trying to remember yesterday very accurately and bid accordingly. And if we get it right, great. And if we don't have enough information, we try to generalize. And if we do a good job at both, we're going to have a good time. One thing that's very important for us as a company, especially from people that didn't come from machine learning at all, was transparency, both for ourselves and our clients. This is why when you're designing a machine learning product, sometimes you have to be transparent. For example, if you're trying to predict how much a person should pay for his insurance policy, you have to be transparent legally. But if you want to explain what you're doing and to be able to improve it, you need to cook in explainability from day one. This is why we have these visualizations that really take our tree-based models and help us explain what's actually going on inside. This way we can optimize them. All of these models eventually follow common sense. Even the newer network-based ones that are more complex, they have more loops and games around them, let's call it, but they follow the same common sense, trying to distinguish between ones and zeros, with ones being installs or high-value users. One thing that's nice about this approach is that we had a few cases where we worked with advertisers that were able to take our insights and apply them on social and start targeting demographics they didn't think about and opening new opportunities for them. What we're seeing here is an example of a feature importance graph, which we share with our clients that really shows us what's the model actually trying to do, right? I won't get into how you read it, but what this says, this example says is that rewarded placements increase the probability of an install. If the context of the app is similar, it also increases it, etc., etc. So we can take this and explain what's actually going on. Jump too quickly. One thing that the entire panel before me spoke about, and we should all speak about, is these changes that we have. Obviously, they impact machine learning and how that's designed, right? So today, we have tracking IDs. We can say this tracking ID led to an install, and this one isn't, and this is the way you build a model. In the near future, we won't have that anymore with Scan 4, Scan 5, whatever it would be. This is why we build models that are based on weights of like contributing factors to an install, even when you don't have a deterministic connection between an impression and an install. The reality is that as soon as ATT hit, what we saw was a huge decrease in prices. Basically, all the budgets went to Android because people were panicking, makes sense. And the signal obviously decreased as well, right? We had probabilistic attribution. We all know what that means, and we were still able to work with it. But the prices decreased more than our capability to still classify users. So if, let's say, the range of IPMs we predicted in a model was between 0 to 20, before ATT hit, it decreased to 0 to 5, but prices decreased at an even higher rate. And over time it plateaued, our ability improved because we added features, so it balances out. Same thing's gonna happen if probabilistic is really gonna be here and, you know, as Apple says, fingerprinting is not allowed. It's going to be the same situation, and on Android with Sandbox, it should be the same. If you still have the ability to distinguish and build a model, you should be fine. When it comes to scan specifically, when we started looking at this, we needed a solution for cold starts, assuming we don't have anything deterministic. What do you have left when you don't have the user anymore? The context is in. So we wanted to create a solution that can utilize this context and capitalize on it. Obviously, we went to machine learning. There are a few different approaches where you can create whitelists of segments of apps that you can target. The most basic one would be spot categories, but if there's any person here doing ASO, I hate you guys, you should stop switching categories. We can't really use that because you keep doing that. Don't do that. Another variation of this, which happens a lot in machine learning, humans tag things. You can create your own categories based on judgment of people. You do this competition. There is a service from Amazon called Mechanical Turk. You can do that. You need to maintain it and hire people. We don't like that stuff. So what we went is with NLP. There's a small joke here about, you know, the other type of NLP, but the NLP inside machine learning is natural language processing, and this allows us to understand the context of apps automatically pretty quickly. We use a model that we didn't train, Google did, in order to create a vector representation based on the store description. In the store description, you can't lie the way you do with your category. So the value proposition is there, and we can create a vector representation of the publisher app and the advertiser app and understand the contextual distance between them. We have a demo on our site that shows this. You're more than welcome to try it out. Sometimes there are hits and misses, but usually it's pretty good. Another thing that machine learning plays a big part in is creative selection. For us, it's more of a tool to get more observations and more targets more effectively. But in reality, obviously, you want to run your champions and you want to be effective. Initially, we had A/B testing, but there are regret costs associated with it. You run A and B in parallel. B was better. You regret paying for A. So we went with something from the reinforcement learning part of machine learning. This is what you would use to train bots for your games, where you give them rewards and punishments based on the results. And this way, this is how it works. It has a fancy name, multi-arm bandit, that doesn't really matter. The explanation is pretty straightforward. Let's say we have 3 creative variations. At the beginning, we don't know who's the better one. They all get equal parts of the traffic. As soon as we get a single install, that variation becomes the champion, and it starts getting more of the traffic. As it becomes more statistically significant, it gets basically 90% of it. So we have an A/B test that optimizes in real time and still has something like 5 to 10% available for exploration because you keep generating a lot more creatives with your creative teams until you're going to switch them with generative AI and have less meetings, I hope. One thing that's still missing in this puzzle on our side is context. Currently, we select only a single champion for all the users, but in reality, they're not the same. You have, even if you're like a very specific niche, you still have a few different personas. So what we're doing now is we're adding features about the users or the publishers they come from, and this way we can select their champion accordingly. This is something we're working towards. It's roughly a 10-12% boost. Finally, some practical tips about working with DSPs, because a lot of you try that. Sometimes it's not the best experience. You need to be ready for it. It's different than working on closed gardens or the networks from back in the day. First thing is making sure you're working with an actual DSP. We're all in AdTech for a long time. We have trust issues for good reasons. Be sure it's not like 2 guys on LinkedIn with like stock photos. It's actual people that can do stuff. I'm saying this because we see this pretty frequently. It's key to share data because this data that comes from unattributed installs feeds the machine, and it learns faster. And that became the norm. So even if you're scared about compliance, you should figure it out, because otherwise you're behind the curve. One other thing, when you're giving a KPI, don't be like, okay, I remember this campaign from 2019 on Facebook that I spent $1,000 on that has 60% day one ROI. That's not really your KPI. Be realistic, be prepared to adjust it. Maybe we'll have a longer recoup period, but we'll likely recoup. Otherwise, again, we wouldn't really exist. This kind of phrase that I'm proud of in terms of like a marketing term, you need to be patient. We can't just show you amazing results from day one. If we do, be highly suspicious. We need to learn, we need to buy, we need to spend. There is an exploration cost. You need to be ready for it, but you need to be ready to also pull the trigger and call us and tell us that we're not going to get there. That can happen. And last but not least, as I tried to depict here, machine learning is straightforward, inputs and outputs, like anything else, no magic. Ask the right questions. Ask your DSP how that works. And if you get a black box answer, I can tell you they're either lazy, because you can't really run black boxes at our scale. It's going to be way too expensive, and your bill to Amazon is going to kill your business. So it's either that, or they're not training their people well enough to communicate what they're actually doing. So yeah, push hard. Otherwise, it's going to be weird. And that's it. I did it. Thank you.